I forget. Yes. So let me repeat this part again. So in quick sort, process is applied very quickly. I am taking this array for our implementation. And what we do is in this process, one loop will start previous side, right? So what we'll do is we'll take one element as a pivot element once, and now what we'll do is we'll compare this pivot element. We'll compare we'll compare this pivot element with uh, the starting of the range, right? So, for example, uh, at first, this one row means this. I mean, this is the index 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Okay, this is the array is there. Okay, so at the starting, this low value will be at 0 and high value will be at 6. Okay, now pivot element will be taken as array of 6. Sorry, array of 6. This will be the pivot element. So at the starting, pivot element is 53. Now this 53 will be compared, means one loop will start from low to high, right? So from here it will start and it will go up to here. Okay, so this 53 first will be compared with this. Okay, so if for this element array of j, so let's say I have started this from let's say I have started uh, length of array um, where so this is our low and this is our high. So what will happen? We'll do a comparison. First of all, a loop will be started. So loop will be like what we can say loop. There is a partition loop. First of all, we have to divide this array into into partitions. So how we can decide the partition will perform? So we'll take this pivot element as this. Now, um, next step, I is equal to low minus 1. So initially this is 0. So this will be starting at minus 1 position. Okay. So then loop will be started for j in uh, in range, and range it will start from low and it will go till high. Okay. So what will happen in this? It will now compare if array of j is array of j is less than or equal to pivot. So now what is j? J is getting started from j is getting started from the low. So low position is 0 and high position is 6, right? So this array of low, so array of 0. So here in this case, first of all, array of 0 is less than or equal to pivot. So here area of 0 is 45 and pivot is pivot is 53. Okay, so here this is less. This element is less. This element is higher. So what will happen? This I will be moved towards 1. Okay, so I is moved. Um, so how I will be moved? I will be moved to this second position, right? Initially, I was at low -1. Now I will be positioned as um, low +1. So I +1 is equal to 0, and array array of I and array of j will be exchanged, right? So here right now you can see here this is this is a mm, this is 53 and this is 45. So initially, this 53 will come here and 45 will come here. Rest all other elements will be as it is. So these all elements will be copied further. Okay. So now next element will be compared. So here now it will go here, and this element means this element will come here, and this element will come here. So like this, it will perform. So basically, first of all, you can say um, at first step this and this is compared. If this is smaller and this is bigger, no, at first step this will not be there. um, this is 53 only. At no, this is greater than or equal to, this is greater than or equal to. Okay, so you can see here, first of all, I'm just explaining the raw, just forget the technical things for now. um, I'm showing you just a small process. Okay, so first of all, at first step, this and this value and this value is getting compared. So these two are getting compared. Now, nothing is found over here. So now, since this is smaller, this is bigger. Okay, so when this is bigger, this position will move here. So now this will be moved here, and this will be as it is. Okay, so now what will happen? Now 53 and 89 will be compared. Now 89 is bigger, 53 is smaller. Okay, so now what will happen? 89 will come here and 53 will come here. Rest will be as it is. So this will be 45 as it is, and others will be as it is. Now, since this has come here, now this will be moved here. This side will be moved up to here. Okay, now next you can see here, now this position value at this position, 53 will be compared with 76. So you can see here, now 76 is bigger and 53 is smaller. So now 53 will move further. Okay, in step, in next step sorry, in this next step, 53 will come out of this, and this 32 will come here. Okay, so this 32 will be compared with 76. So now nothing will be changed over here. Okay, then this 32 will move here. Okay, so here in next step, this 32 will go out of picture, and 70, and this 66 will be compared. Right, so now 66 with 76 it will be compared. Now you can see still 66 is smaller and 76 is bigger. So now this entire thing will be as it is, and 21 will move. Okay, so here now this will come out of range, and this will come here. So this now 21 and 76 will be compared. Again, there will be no change. Um, in the next case, what will happen? Um, in the next case, what will happen is this 70 means 21 will move further, and 76 will be as it is, right? So when 76 is as it is, now what will happen? Um, this 21 will go out of range. Now you can see low and high both will be at 76, right? So both are at 76, low and high both are at 76. So now there is no possibility of further swapping, right? So when there is no possibility of further swapping, now the array will be divided from this, right? So the after when this process is completed, now what's happening is there is no chance of any comparison further, because now it is comparing with itself. So here now low is not less than high. Okay, when low is not less till low is less than high, this process will perform further. Now then it will not perform further. Now what will happen? Now again, in the next round, this low will be moved at further. So now the position of this 76 is final over here. Now next loop will be one comparison will be performed from this to this, means before this till before this, and another comparison will perform with the elements after this, right? So one array will work from one comparison will work from here to here, another comparison will work from this and next of this to further. So here only there is one element, so there will be no change in this, but here this will be performed. Okay, so this was the first iteration. In first iteration, what has happened is one element, that is 76, has found its position, right? So this is the target of doing this exercise, is that at least one element has found its position, right? And numbers before this are the smaller than this, and number after this are all bigger than this. So view means position of 76 is fixed. Now this will not move further. Now elements will move at this side, and elements may move if at after this also, but this position is fixed. Is it clear somewhat? It is somewhat clear. Yes, no. I know this is little confusing because of its nature. Because
So can you
uh,
repeat once? So,
sorry.
so can you repeat this once?
Yes, yes, definitely. I'll repeat this. Okay. So let me take it and another way. I'll take the code and I'll write the code, and with the help of code, I'll
Kushal,
explain
Kushal,
this again.
I,
Yes.
so can you please repeat here itself one more time?
Sorry?
Precisely. So yeah.
Your voice is breaking up, Sharmila.
So can you please explain here itself one more time briefly?
Okay. Okay. Let me repeat this again. Okay. I'll delete this part. Okay. At initial, let me take some. Should I take some other numbers? I'll take some other numbers now. Okay. So Okay, so I have these numbers now. Now what we are going to do is we will start a loop from this side and another loop from this side. Okay. Now we'll compare first element with last element. Okay. If the first element means element from left side is bigger than the last element, we'll perform a swapping. And once swapping will be performed, will move one element uh, from the from one side. Okay, so first of all 65 is and 18 are compared. 65 is bigger, 18 is smaller, so 18 will come here. Since we are doing it in ascending order, so 18 will come there and 65 will come here. Okay, now rest element will be as it is. Okay, these elements are as it is. Now what will happen is, now since this comparison has been performed, so now what will happen when the comparison has been performed, so at this point, now will move the element from both side. Okay, so this element will come here, this element will come here, and this element will come here. Okay, now this 76 and 32 will be compared now, right? So now 76 is bigger and 32 is smaller, so this 32 will come here and 76 will come here. Okay, now what will happen, this will be as it is, this will be as it is, and this will be as it is. Okay, now this and this, these both will be compared. Okay, so now since this is bigger and this is bigger and this is smaller, so there will be no swapping, and element from one side will be moved, right? So here let's say I am moving this 50 from here to that's there. So this 54 will go out of picture, and this will come at 87, and here this is now. Okay, now this 54 will be compared to 89. So nothing will be changed. So now again, let's say I am moving this 87 to next space, right? So now this 81 will go out of 87 will go out of picture, and it will this will also move to its next. So now here you can see this is also so this is now 87 means loop from the left and loop from the right both are at same place, right? So when loop from the left and loop from the right both are at same place, now what will happen? Now the element will be divided from this space, right? So now next time another loop will run from this place to this place, sorry, this place to this place, and then this place to this place. Okay, so one comparison will now separately perform from till before this, and another will separately perform from this to last. Okay,
Okay.
so
Yes, sir.
we'll keep on performing, keep on moving from left to right and right to left till let's suppose it is starting I from here and it is starting J from here, right? So we'll keep on moving I towards right and J towards left till I is less than J. Okay, as soon I either I is equal to J or I is greater than J, this loop will be start, and the this entire part, this comparison will be divided into two part. Now there will be two separate loops processing the same thing again. Okay,
Okay.
okay. So this is the way we will sort this part. Okay, so now let's see how we'll perform this. So in quick sort, uh, first of all, there will be a um, dividation array, right? So two functions will be there. First of all, there will be quick sort will take, and in this quick sort, what we'll do, we are taking an array, okay, where low will start from 0 and high position will be none for now. And here we'll take if high is none. If high is none means um, what we'll do, high high is equal to length of array minus 1, right? So like this it will start. And if high is sorry, if low is greater than high, will perform this calculation. Um, if array of j, not array of j, right? No, 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 not right now. First of all, we have to perform an partition function, right? So in partition function, we'll do pivot index is equal to and partition array low and high. And once the partition is performed, we'll again call this quick sort as a recursive function in array. Array is will be starting from low till pivot index minus 1, and again quick sort array pivot underscore index plus 1 comma I. Okay. So this is the quicksort function. Now we'll make this partition function. So partition per function will work like define partition and array comma low comma high. So we discussed this pivot element. Pivot is equal to array of I, array of I, and I is equal to low minus 1. So for j in range low comma high, j in range low comma high. Now we'll do this processing of moving further or moving backward. So I plus is equal to 1 and array of sorry. First of all, comparison. So if array of j is less than or equal to pivot element, okay, then I plus is equal to 1 and array of I comma array of j is equal to array of j comma array of I. Like this it will be exchanged, and at the end array of I plus 1 comma array of I is equal to array of I comma array of I plus 1. By this will be performed, and then we'll return I plus 1. Okay, now, so this should be done. Now I'll create an array. My list is equal to, and let me take these elements. Where was this? Let me take these elements as the input. 65, 76, 54. 55, 76, 64, 54. Okay, 65, 76, 54, 65, 65, 76, 54, 87, 94, 32, 87, 94, 32, and then last is 18. Last is 18. Okay, now I'll print this list. Print initial array. So this is my list, and then I'll print this array with the quick sorting. So quick sort, here I'll pass this my list, and then print final array. So here will be again my list. Okay, so now sorry, array minus 1 here. It's not sorted. Oh, it is not sorted.
Array
What
J
else?
is less than or equal to pivot or less than pivot.
Sorry, J is
Less than or equal to pivot or less than pivot.
this. This is fine. Low is great. No, this is low is less than high. I was doing just opposite. Okay, now it will work. Yes, so it has worked now. Okay, so here what you can do is you can just if you want I'll just put some print statement so that you will be understanding how this has been done. So this I'll just print my list. Okay, and now I'll execute this. So you can see this first at first part. This was the initial array. This has been sorted step by step. So at first part, you can see here this was the initial array. At first part, just all elements are same from here to here. It is same. Only this 18 has come at starting, and this 65 has moved over here. Okay. Now, in the second part, what now this the comparison will be performed in this portion, right? So now you can see here 76 means 76 has moved from here to here, and 30 and of this 32 is moved from initially from this place to this place, and then this 54 has been moved to this place, right? um then in next you can see here this 32 has moved to this place, 54 has moved to this place, and 65 has come over here. So like this, step by step, this has been done at the last. Means it has already achieved its sorted put, all elements has achieved sorted position at this point itself. Okay, but since it has to process whatever it needs, so that's why it has taken one more step, and this is finally sorted. Okay, understood. Any doubt with this? This might seems little confusing because this quicksort algorithm is a little tricky algorithm, because one thing is working from left, one thing is working from right, and then values are getting exchanged. That all process is getting being happen. So it might seems little confusing. Okay, you can try with another example. So like here now you can try it like let's say 56, 32, 78, 97, 22. So then 57, 21, 90, 33, 79, 107, 31. Like this you can try. You can see here it will take more steps. So in this also you can see how this entire steps are getting performed one by one. Okay, so this is for your own reference, or what you can do is you can do printing, and you can see how values are getting exchanged. Okay, so here let me take one more step over here. Print my list. I am printing at one more time, so it will be more clear. So I'm taking this in loop, and here this is out loop. So initially, you can see what's happening is in inside loop it is getting performed. These comparisons are getting performed. So in the loop, first of all, 20 here. One more thing I am taking um, print divide from, and here I'll be taking this print sorry, my list of I. Okay. Mm. Okay, so you can see here, first of all, um, what values are getting exchanged in values exchanging. So here you can say print, no, array of I, comma j dot format array of I, comma array of j. It is giving error over here. Yes. Okay. Okay. So now it must be crystal clear to you. So first of all, it is starting from this place and this place. Okay. So first of all, 56 and one more thing. Yes. Print pivot value is equal to. Okay, so initially at initial pivot value is at this place. Okay, initial pivot value is this, right? And so one loop is starting from this side for J, and loop is starting from this side for I, right? So this this and this will be compared. Then this will be at the same place. It will move at this place. This will be compared with this. It will be it will not move. This will be compared. This will be compared. This will be compared, and this will be compared. When this and this will be compared, this and this. So first of all, at first position, the exchange will be performed between 22 and 56. So now what's happening? 56 has come at this place and 22 has come at this place. At second point, this will start again from this place, then 20, 21 and 32. So 21 will be moved at this place and 32 has moved at this place, right? Now, since the low will be greater than high, so it will be divided from 21. So from this place, this entire part will be divided, and this will be taking this place. So 21 will come here, 30, 22, 31, like this. This entire process will be performed. So you can see step by step how these things are getting processed entirely. Okay. This is a little tricky. Don't worry, I'll explain this again, this entire part, if you do not understand in this session. If you want, I'll explain this entire part again. Quick sort is the most difficult sorting that to understand because it involves lot of exchange values and a lot of inputting values. So it is very much complex situation.
It is very
Okay,
important.
sorry.
It is very important.
Shamila, I'm not able to understand this.
Is the quick shot is very important compared to other sorting.
So, see, the algorithm that we are studying in DSA are useful from the logical development part. Okay, you are not means if we say in with the perspective of data engineering, you're not going to implement any of these algorithms in future, but some of these concepts will be used further in PySpark and the means database scaling part. Okay, some of these concepts will come. Okay, so if you are not able to understand, don't worry, I'll explain this again. But just if you understand, your logical part will be stronger. Clear? Okay, let's not waste much time over here. We'll move to another algorithm that is comparatively simpler than this. Sort. Let me explain the next algorithm. That next algorithm is of merge sort. So what is merge sort? So in merge sort, um, here in merge sort, this is very simple. Um, Means not as simple as the selection sort and bubble sort, but comparatively very much simpler to the quick sort. So what we do in this merge sort, so we divide array into smaller parts. Okay, and till when smaller parts recursively will divide recursively again and again till each element till element becomes the individual array. Okay, we'll divide it till each element becomes an individual array. Okay, this is the first step. I'll explain through the example also. Then in second part, we start combining the individual elements in sorted order. Okay, in sorted order, and arrange all sorted arrays into sorted order. Okay, for example, let's see. Let's say we have 64, 20, 25, then 64, 34, 20, 25, 12, 22, 11. Sorry, 12, 22, 11. And let's say I have 90 and let's say I have 5. Okay, so now we have how many elements? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 elements we have. Okay. Now what we'll do is, first of all, we'll divide this array from the middle. So 4 element and 4 element. So one array will become on this 64, 34, 25, and 12. Another array will become 22, 11, 90, and 5. Okay. Now further, these two arrays will be divided into two parts again. So this will be 64 and 34. This is the one part. Then 25 and 12. This is the second part. Now this is 22 and 11. This is the third part, and then 90 and 5. This is the fourth part. Okay. Now each array. Now we have four. Initially, I have one array of 8 elements. Then in second step, I have two array of 4 elements. In third step, I have 4 array of 2 elements. Now at the next step, we'll have 8 array of 1 element. Right. So 64, 34, 25, 12, then 22, 11, 90, and 5. Okay, so now I have 8 array of one element. Okay, understood? Is this clear? Is this clear?
Sir, will this work? Will this work if the elements are not in even order, like even numbers? If the number of elements is odd.
Yes, yes, yes. That time also it will work. No worries. Algorithm is designed like that in that way. Okay.
Yeah, okay, sir.
So it may be even numbers or it may be odd numbers also. No worry for that. Okay. Now I have eight elements or eight array of single element. Now what what will happen? Now we'll start combining. Now since this is divided till individual array, now we'll start combining. So how we'll start combining? We'll compare this 64 and 34, right? So whichever is smaller, that will come first, and another array will come after that. So 34 and 64 has come here. Okay, now 25 and 12 are will be combined. So 12 will come first and 25 will come second. Then 22 and 11 will be combined. So 11 and 22 will come here. And then at the last 90 and 5. 90 and 5 are here. Last element 90 and 5. So 90 and 5 will be combined. So 5 will come here and 90 will come here. Okay. So now again we have four arrays of two elements. Now this time situation is changed. Now all arrays are in ascending order sorted. Okay. At this seventh line, there were four arrays, but they were not in sorted order. Now these all arrays are in sorted order. Okay. Now these two arrays, which are already in sorted order individually, they will be combined in a way so that there are all four elements are in sorted order. So it will become these two arrays will be merged in a sorted manner. So 12 will come, then 25 will come, then 34 will come, and then 64 will come. Okay. And in the second part, now first of all, 5 will come, then 11 will come, then 22 will come, and then 90 will come. Okay. Now in this 11th row, we have two array of four elements, and both arrays are sorted. So here these both arrays were not sorted. Now these both arrays are sorted. Now these two sorted arrays will be combined together in order to make one sorted array. Okay. So this 5 now will come first, then 12, then 5 and no, then 11, then 12, then 22, then 25, then after 25 what is the bigger? 34, then after 34 5, 11, then 64 will come here, and then 90 will come here. Okay, so now you can see here, this is the when one array, all elements are sorted. Okay, understood this process? Is this clear to everyone? Yes, no?
So combining, can you explain? So combine, how did you combine it?
So see, very combining is very easy. So these are two elements with single element. Now whichever element is smaller, that will come first, and whichever element is bigger, that will come second. Okay. So this will happen in all four combinations, in for all four combining. Now we have these four sorted elements are there. So now we have these two arrays, and in these two arrays, all elements are sorted. Now when these two will be combined, it will be checked whether this is bigger or this is bigger. If this is bigger, then the smaller will come first, and then this 34 will be compared to 25. Then 25 will come here, right? And after that, this 34 and 64 will be combined over here. Okay. And in this case of four sorted elements, sorted elements over here. This will come here, right? Now 12 will be compared with 11. 11 will come here. Now this 12 will be compared with 22. So 12 will come here and 25 will be compared with 22. Okay.
Yeah.
And this then 20 and then it will move to 90. So 25 will be moved, no, will compare with 90. So 25 will come here. Okay, now 34 and 90 will be compared. So 34 will come here. Now 64 with 90 will be compared. So 64 will come here. And at last 90 will come. Okay,
Yeah. Yes, sir. Okay.
understood how the sorted arrays are getting combined for you,
Yes,
Sharmila?
sir.
Sharmila, is this clear for you?
Yes.
So this is comparatively very easy. Let's make program for this. How we can do this? So here we will have two process. One process is merge sort, where we'll combine, where we'll divide the arrays, and then there will be a merging process. One process is the dividing process, and another process is the merging process. So we'll just define merge sort, and we'll pass array over here. And if length of array is greater than, sorry, is less than equal to 1. So this will work when arrays are, when there is at least more than one element. Okay. So return if return array, no, nothing to be processed. If this is greater than 1, then and this further process will be there. So we'll find the, first of all, we'll find the mid position for the dividing. So length of array divided by 2. Okay. And the left half, what we'll do is from starting to mid will go. So ARR of starting to mid. Okay. I hope these things are clear what I'm writing. Right half is equal to ARR of, it will start from mid to last. So is this clear what we are doing? We are just dividing the array in two parts. So left half is till mid minus 1, and right half is starting from mid till last. Okay.
Yes, sir.
And now we'll um, do the sorted left is equal to, again we'll call the merge sort, and we'll pass this left half in first part, and sorted right, and we'll call this merge sort in with the right half. Okay, so like this, that it will be recursively called, and at the last we'll call this when means till here array will be divided individually till the array becomes the single entity for each value, right? At this last, what will happen? Merge, and this will be sorted left and sorted right. Okay, by this division, now we'll call the merging. Now we'll call the merge. We'll create the merge function. So this merge is left and right. Okay. So now what we'll do is, again we'll create an initial array, that is blank array, for the combining purpose. I is equal to 0 and j is equal to 0. Okay. So what we'll do is, while I is less than length of left, and j is less than length of right array. Okay. What we'll do is, if left of I is, if left of I is um, less than right of j. Okay, so when I part is smaller, then we'll append I. So result dot append of I and I plus is equal to 1. If this condition is false, then we'll do the same thing with the right part. So result dot append j and j plus is equal to 1. Okay, and at the last, when one part is over, we'll do result extend and left of I till last and result dot extend right of j till last. Okay, and finally we'll return the result. Okay, now we'll take array. So merge list is equal to, we'll take few elements like let's say 64, 34, 25, 12, 22, 11, and 90 comma 5. This is the same element. Yes. Okay, so now print initial array, and this is merge list, and then we'll call the merge sort list is equal to merge sort, and we'll pass this merge list and print final sorted array sort list. Okay, so let's see merge sort. Why it is giving error? Which object is not subscriptable? Merge sort list. Which object is oh sorry. ये क्या कर दिया इसने? Oh sorry. This is left of I and this is right of J. Right of J. Yes, not work. Okay, so this is sorted. Understood this? Is this understood? Do you want the extended version of this also, like we did for quick sort and insertion sort and all? You want this?
No, sir. It's fine.
So are you able to understand what is done in this?
Yes, sir.
For you,
Yes.
if at any point of time, if you are not able to understand, just let me know. I'll explain the entire part again. But understanding is important for your logical development. This part, the DSA part, little, not much, and it will take some time for the understanding. Rest of part is not that logical or technical. That will be just implementation part. This is the logical thinking part as well. Okay.
Okay.
So you have to do the practice as much as possible for this part only. Rest part will not be that much programmatic. Any doubt in this? Okay. So should we keep it at this or should we continue further?
Sir, gives us some time to absorb this.
Okay.